And then once we start the midterm, I'm going to pause the recording. I don't want to record the duration of the midterm. Once the midterm is done and it's submitted, then I'll turn the recording back on and we'll record the rest of today's lab when we do the PowerPoint. Okay, so I'm going to share my screen. Which one do I want? I guess this one. So question 1 talked about completing the average end area calculation for the access road. The question was, what's the total cut and fill volume? So I provided this blank spreadsheet to you. So you needed to put things on here like the stations. So 0 plus 100 up to 180. Of course, the distance between each one, they're all 10 meters. So these two areas here is where you would have to calculate your cut and fill area on each cross section. Alex, yes, you can ask questions during the midterm. So let me share a different screen to show the cross sections. So this is an on-screen takeoff software. This specific one is PlanSwift. So that one's kind of hard to see. Here's a good one. So 0 plus 110. So the blue area is the area that you should have calculated for the fill. This white rectangular strip is the road structure for the path. Sorry. You can't see my screen. Okay, why is that? This one, share. Okay, how's that? Can you see the cross section?
Yeah.
Okay, perfect. So 0 plus 110. So the blue shaded area is what you should have tried to calculate. So you would not do this white rectangle because that's the road structure. So you're told that this access road is made up of subbase, base, and millings. So that's what this rectangle represents. That would be taken off separately. So again, so the fill that you're trying to do the end area for at this station is this blue area. So you're coming up the slope, you're going to the underside of the road structure. You're doing this slope, and then you come down to the dashed line, which is the original ground surface. So for this assignment, we said to ignore any stripping. So normally when you're doing a calculation like this, you lower the original ground surface down some amount to account for stripping. You didn't need to do that on this question. So that was a typical fill. This is a typical cut. So 0 plus 150. So shaded yellow. Now for a cut situation, you would include that white rectangle that previously we excluded. Because we need to excavate to the bottom of that surface. In order to fit the entire road structure in, we would need to excavate down to this layer down here. And then of course the slopes that are shown. So that's a typical cut. I think there's 1 or 2 that have both. That one's pretty small. This one also pretty small. This is probably the best version that we could look at for a cut and fill. So 0 plus 100. There's a tiny little fill triangle here that would amount to almost nothing. Very hard to measure that. And then similarly, there's a small triangle for cut. So here is the dashed line of the original ground surface. So we would have to excavate into that in order to fit the entire road structure. Looking at a question here. Okay, Arvind, I see your question. Try to submit it after the midterm, maybe after the PowerPoint presentation. I won't mark it late if it's a few hours late tonight. So at some point tonight, it should get handed in. Your question, which we do is 0 plus 180. There is no section for this. So 0 plus 170 was the last one. So there's no cross section for 0 plus 180. So you would take these end areas that you calculate for 0 plus 170, and you can extend them out to 0 plus 180. Is a way that you could deal with that. Alex, you had the same question as you. Is that your same question? Yeah, so the end area at 0 plus 180, you could say is the same as 0 plus 170. So those were the cross sections. If I stop that share. Okay, let's go back to the Excel spreadsheet right here. So so that's what I've done here. So I did the calculation for the cuts and fills at 0 plus 170, and I carried them through to 180, same numbers. So you should have, after you do your averaging, right? This cell averages these two cells. Similarly, this cell averages these two cells, and so on and so forth. So once you get these averages for the cut and average fills, then in your volume columns, you simply multiply your average end area per cut, multiplied by the distance, will give you the volume for that section. Do the similar thing with the fills. So average fill area between these two stations is this one, multiplied by the distance between the two, gives you the fill volume between those two stations. So you would carry that all the way down and then total at the bottom. So as long as you got similar numbers to me, I didn't take any marks off. I did give you some leniency either side. So you could have been higher or lower than this number, and similarly higher or lower than this number to a certain degree. If you had 120 cubic meters for fill, I would have taken marks off. Okay, so that was question 1. Question 2 was completing the material takeoffs for the access road. Nima, yes, question? Go ahead, Nima. Nima, did you have a question? No? Okay. You can unmute yourself and ask your question if you like. Bruno, you get a little confused about density to use for the different gravels. So normally I give you the density to use. So that's part of the assignments, is listening to what I have to say. I'm going to change it from week to week, simply because previous terms have used certain densities that I don't want to continue to use the same densities. Typically in the real world, if you want to write this down, road subbase and road base, you could use 2.2 tons per cubic meter or 2.3 tons per cubic meter. Somewhere right in between those two is the actual density, compacted density of those two types of materials. Yes, that's the exact reason, Alex. Other types of materials like maybe sand is a lower density. It might be 1.6 or 1.7 tons. So those are, just for clarity, those are metric tons per cubic meter. So a metric ton is 1,000 kilograms, which is 2,200 pounds. So those three materials. So the fourth one, maybe for clay and silt, maybe clay is a better example. You could use a number like maybe 1.8 or 1.9 tons per cubic meter. Again, those are compacted densities. So after you've placed the fill and you've compacted it with your roller, that's what the density will be of those various materials. Where would you find those densities? If you Google it, I'm sure you can find various numbers. I get those numbers just from working in construction for so long and seeing density reports. So when I have a quality control subcontractor come to one of my job sites and they test the density of the road base or the road subbase or the clay embankment fill, I see those reports. So I see what the compacted numbers are for those various types of materials. And as I've previously said, if you rewind the video a minute or two, those numbers that I provided are typical values for those types of materials. The supplier might know. They could give you approximate values. A quality control firm would be able to tell you, because that's what they do, is measure the density of those compacted materials on a daily basis. Okay, so getting back to the review of the previous assignment. So this first one here, the cut fill, all I wanted you to do was add up these two numbers. So I wanted you to determine what the total cut and fill was for the access road. So that would go in there. So the sub base. So some of you got confused with thinking that the thickness of the sub base layer was 75 millimeters. That's incorrect. That's the biggest size of rock in the sub base material. So the thickness of that layer is provided to you on the drawings. It was 200 millimeters. So for this calculation here, you would go, so our access road started at 0 plus 100 and it went up to 0 plus 180. So the difference between those two is 80 meters, right? 180 minus 100 is 80. So that's the length of our road. The width was given to you again on the drawings. The width was 4 meters. So your calculation here was 80 meters times 4 meters wide times the thickness of the subbase, which is 200 millimeters or 0.2 meters. So if you multiply those out, so 80 times 4 times 0.2, you would get 64 cubic meters, right? I gave you these units. So this was given to you as part of the quiz, or not the quiz, the assignment. So you're looking for cubic meters here for subbase. So the next one down was how many tons of subbase did you need to buy? And that was simply multiplying your calculated cubic meters here by the given conversion that I provided to you. So it's 64 times 2.3. So about 147 metric tons. No, as I said, Bruno, it wasn't written on the assignment. I verbally told you 2 weeks ago, yes, when the assignment was provided. So when I'm issuing assignments, big truck going by blowing his horn. So when I'm issuing assignments, you're downloading the paper copy. I'm also giving you verbal instructions. So everyone needs to be paying attention to what I'm saying. So that was subbase. So base, again, the thickness of the base is again provided to you on the drawings. That was 100 millimeters. So again, there was some confusion on this 19 millimeter base. That's not the thickness of the layer. That's the biggest size of rock. So 19 millimeters, which is 3/4 of an inch. So the biggest rock size is 19 millimeters. The thickness of that layer is 100 millimeters. So again, you're calculating length of 80 meters times 4 meters wide times the thickness of that layer, which is 0.1, which would give you 32 cubic meters. Again, for the metric ton calculation, you're simply multiplying the 32 times 2.3, and you get about 74 tons. Now for this one here, this asphalt millings, this is a type of road surfacing. So it's ground up asphalt is what it is. Now notice the units. A lot of you didn't realize you were looking for an area here, not a volume. So meter squared is area. So you're not multiplying an area times a thickness. You're not trying to calculate volume. You're trying to calculate area. So the area of millings is simply the surface area of the access road. So it's simply 80 meters long by 4 meters wide. So it's 320 square meters. The last one here, you simply had to pick off on the drawings how many signs were shown. And I believe there was 9. So the last question, prepare a list of activities. So a minimum of 5 to construct the road. So you needed to list your activities. And then for each activity, you were asked to put down labor and equipment that could be required for each. So the first one, layout, you could have said things like a total station, so that would be the equipment, and surveyors, so that would be the labor component. The next one is the excavation, or the cut, as it's also referred to. So when you're excavating, you typically do not use a bulldozer, or a dozer as it's called. You use an excavator. You wouldn't use a loader either. 95% of the time when you're digging something, you're using an excavator. So you have an excavator, you could have a dump truck to haul that material away. So you would also have operators for those machines. You could also have included a labor type person that is on the ground at the cut measuring the depth. So even though the surveyors have gone through and pounded in stakes along the alignment, you need a person that's not in a machine that is measuring the depth of the cut to ensure that the excavator is digging to the proper depth. So I didn't take marks off for that, but you should know that extra person is on the ground to measure the depth of the cut, or similarly the height of the fill to make sure that it's at the proper height. So that leads into the next one. So the fills. So fills are you're placing material on the ground. So that's where you would use a bulldozer or a dozer, a compactor to compact that material. You would have operators for those machines. You could also have a that extra labor person on the ground measuring the height of those fills. So for the next three, they would be similar type equipment and people. So sub-base, base gravel, and then the millings. So all of that is, all three of those are being, so again, you're putting material on the ground. You're spreading it out and you're compacting it. So sub-base, base, and millings. So you could be using machines like the bulldozer. I would have also accepted a grader instead of a dozer for these three items. So you have that machine spreading the material out. You then have a compactor compacting it. You have operators for those machines. And again, you could have included the extra person to measure the height or the thickness of those three individual materials that are being placed. Again, I didn't take marks off if you didn't have that extra person. The last one is sign install. So signs. So that one is typically a couple laborers, so 2 laborers, say, and some type of augering equipment. You could do this by hand, so it could be a couple laborers with shovels, depending on the number of signs that you have to install. If it's only a couple, maybe you make do with just a couple shovels. If you have 100 signs to do, you probably want to rent some type of piece of equipment to auger the hole in the ground so that the base can go in. And that was the last question. So any questions on that exercise other than what has already been asked? No? Okay, so I'll close that spreadsheet. And that. Okay, so at this point, I'm going to pause the recording so that any of you that are writing the test still can come back to the video later and review. Okay, so general conditions. So these are also sometimes referred to as indirects or indirect costs. So general conditions, a written portion of the contract documents set forth by the owner. General conditions usually included in the book specs. So it says they're closely associated with overheads, so overhead costs. So that last bullet there is the important one. The effort, and in brackets cost, required that is not specifically a part of the constructed works. So an indirect cost is not directly attributable to any specific item on the project. So things like a site office are considered an indirect cost. So you typically need a site office, but the cost of that site office cannot be associated with any specific task on the project. So costs for general conditions are kind of lumped together by themselves. So the first one, site office. So can be also referred to as a lunchroom. So some things to consider. Is it powered? So if so, by whom? So can you connect to the existing overhead hydro system? Do you need a generator? Things like that. Does it have telephone service? In the old days before cell phones, we, the contractors, had to bring in overhead TELUS lines to the site trailer. That was a requirement. Now with every single person on the planet basically having a cell phone, that's no longer needed. Servicing of the site office. So it needs to be cleaned. You need to have potable water, so drinking water. You need, you know, supplies, the desks, filing cabinets, etc., all that stuff. So garbage disposal. So all of those things are costs for a site office. The next one there related to a site office is washroom facilities. So does the site office have its own bathroom inside? That would be a pretty fancy site office. Typically the ones that we see on kind of our job sites that we do are, it's a trailer, so it's pulled to the site. It's like a cube, basically, like a shipping container almost, but with doors and windows. You would then provide a separate washroom facility. So the porta-john, as it's called. So the little porta potties that are delivered and set wherever you need them. They're serviced by the company that rents them. So photo on the right is the porta-john. So I'm sure you've all seen those around. There's different colors, different suppliers of them, different rental companies that rent them. The site trailer on the left is kind of the one that I was referring to. So maybe it has two doors. Possibly there's two separate rooms inside. There's some windows. This one looks like it has air conditioning. There's an AC unit there. So you'll notice it's on wheels. So it can just be picked up by a specialized truck, dragged to the next job site, and there's your site office. You still need to connect all the utilities, etc., power. You still need your porta-john, that type of thing. So utilities, so here's a site power box. So you could run the overhead hydro, you could get a service down from the overhead hydro lines, connected into this box. And then this box can then be connected into your site office to power that. You can also have plugs here for, you know, small tools to be plugged in, that type of thing. So there's a cost to this, to installing it, to having hydro connect the lines into this. Usually an electrician can do that for you, but you do need BC Hydro's permission to do that. Photo on the right here is communications radios. So depending on the type of project, maybe you need CB radios. Maybe that's the way you communicate on site. Maybe the job site is big enough that you need radios. Maybe you rely on cell phones. That's also a possibility. There's a cost to cell phones. Having your employees use their own personal cell phones for company business on a daily basis. Typically, employees do not like to do that, so they need to be compensated somehow. So that compensation should be included in your estimate. So cost of cell phones. So our next heading is security, public safety. So what are the security requirements? So is security required? If so, who's providing it? So what level of security? So do you need fencing and barricades for the public to keep them out of work zones? So that's kind of a public safety, a barrier to keep maybe pedestrians from, I don't know, falling in a hole for a building excavation. The next bullet down there, there's a guard. So do you need security? Do you need someone on site overnight, as it says there, in the evening hours, and then 24 hours a day on the weekend to be a security guard? So to keep out the people that want to break in and steal your tools and your equipment and vandalize things. So that's an option. Another good option is cameras. This is what my company actually uses, is monitored camera systems. So there's a cost to that as well. They work quite well if they're monitored. So again, there's a monthly rental price for that camera system. that you have to pay the camera company. That could easily be $1,500 to $2,000 a month for that rental system. Whereas the patrol guard, depending on the hourly rate that you're paying and the hours that they're working, that could be $8,000 to $10,000 per month. So significantly higher cost than the camera system. But again, how big of an area do you need to monitor? Do you need a whole bunch of cameras, or will 3 or 4 suffice? Do you need 2 security guards? So all things to keep in mind. So do you need security to as a requirement of your insurance company? That also happens. Again, your insurance company would tell you that. So next bullet down, so site lighting. So do you need portable light towers? So those are rented units that you rent from equipment houses. So they run off typically diesel generators. How many hours per day or per week will it run? So you need to calculate your fuel into that. So here's a site security guard. So maybe it's a big enough operation. They've got their own security little cubicle here that they can stay in. Hopefully they're wandering around the site, keeping the unwanted people out. Here's a light tower for the evenings that can be turned on. So here's your security fence. So it's some type of metal fence with some fabric attached to it, so that it prevents pedestrians from seeing inside of what's going on. So that's also used, security fencing. So the next main section, kind of health, well, I guess it relates to health and security. So safety controls. So work needs to be performed according to government regulations. So WCB is what I mean by that, Workers' Compensation Board. Your work that you do on the project needs to be in accordance with your company's health and safety plan and any corporate procedures that you may have. So if WCB says, based on the ground type that you're in, that you need to slope your excavation at 1:1, but you go ahead and say, well, it's going to be cheaper and quicker for me to do vertical excavation. Well, not only are you likely going to kill somebody, but you'll get fined by WCB and your job site will be shut down. So it's going to cost you a whole lot more in fines and injured people than it will to build the project safely. So that's definitely something to keep in mind, is work safe requirements. So controls can typically include things like first aid coverage. So depending on how far away you are from the nearest hospital, how many workers are on site, and how dangerous your work is, all things that WCB has tables on that you can go into and calculate. WCB will tell you in those tables what kind of first aid coverage you need, whether it's one first aid attendant with a level 1 first aid ticket, or do you need a level 2 ticket or a level 3 ticket, etc. Personal protective equipment. So again, depending on the type of work that you're doing, you will need to either purchase or rent the required PPE. So fall protection, respiratory protection, all different sorts of things like that. Hearing protection, gloves, eye protection, all that sort of stuff. Other controls. So are they site specific or task specific? So do you need training on that stuff? So kind of relates to PPE. You need to likely do some sort of regular tailgate meetings, whether they're daily or not. It's kind of up to you as the contractor. Task assessments. So all this stuff is safety related. All of it takes time. All of it needs to be done by somebody. So whether it's the safety officer, as shown here, or it's the supervisor running tailgate meetings. So all that stuff, your employees are getting paid while they're going through a tailgate meeting. So maybe it's the first half an hour of each day. So sometimes contractors will include that cost in their estimates. Other times they won't. My company does not include those costs in our estimates. Just for your knowledge. But all of these things cost money. So what you include in your estimate is up to you as the estimator, as well as your boss, who's telling you what to include and what not to include. So relating to the level of first aid that you need, sometimes if you're really far away from a hospital, you're required to have a specific vehicle that can take an injured person to a hospital. So you don't rely on an ambulance, for example. This photo here on the right is, the heading is tailgate or stretch and flex time. So some of the bigger companies like Peter Kiewit and Sons, they do this morning stretch routine. It helps with morale. It reduces the amount of sprains and strains that employees seem to get. Now you can see there's dozens of employees on this job site, so it's a fairly big project. Not all companies do this. So the next major heading, environmental controls. So work is performed according to a whole bunch of different regulations. So there's best management practices, there's governing bodies or governing regulations. There's the environmental management plan that is produced for the specific job, as well as your own company corporate procedures. So I'm not going to go into detail on all this. This could be its own course in itself. But environmental controls are significant and can be costly. Some controls include these bullets here. So things like street sweeping. So if you're hauling excavation off-site, or even if you're hauling imported gravel to the site, those same trucks need to turn around and leave. So you need to keep the streets clean. You can be fined quite easily or your job shut down if you're tracking mud out onto municipal streets. Another method of preventing this from being needed is having a truck wheel wash. So again, there's a rental cost to that and a maintenance cost to that. But if you've got a lot of trucks going on and off site, maybe this is a thought. The trucks go over the wheel wash as they leave. Other things like silt fence and catch basin sacks, we looked at those on a previous PowerPoint presentation, as well as water treatment. So you're treating water that's leaving the site. So is it silty? Does the silt need to be treated in some fashion? You cannot allow silt-laden water to leave your job site. It needs to either be removed with chemicals, or the flow of water needs to be slowed down enough through things like silt fence and hay bales that the silty water falls out of, the silt falls out of the water and settles to the bottom, and the slower moving clean water is allowed to leave. Things like temporary sediment ponds can help with this. Covering excavation stockpiles with plastic or poly, so to prevent that erosion. So when it rains, an uncovered stockpile of dirt will erode, and all of that dirt will find its way into catch basins. Another good way to have your job shut down and fined significant dollars. Depending on the job size and the environmental requirements, you may have a designated site representative that only looks after environmental duties. So there would be a cost to that person for the duration of the project. You know, if they make $5,000 a month, the job's 10 months long, that's $50,000. So again, here's our silt fence picture. So preventing silty water from going into this storm system and finding its way into the fish-bearing streams. So here's a stockpile of some type of excavated material. So it's covered with poly. All those little dots are probably either tires or maybe sandbags holding that poly down so it doesn't blow away in the wind. Again, doing something like this, putting this cover on, would take hours and hours and a significant amount of poly. So there's a definite cost to that. So there's your street sweeper on the left. I'm sure you've seen those. Typically they show up in the spring. So after the winter, all the sand and the salt that's been put on the roads, the street sweepers will come along and clean up all that mess. Also used for construction, of course. Truck wheel wash. So here's a truck leaving a job site. It's being washed. So there's spray jets in behind these panels. There's a big tank on the bottom that catches all the dirty water. So the water is just recycled. So it sprays onto the truck, drops down into the tank, gets pumped back up again, sprays the truck. So obviously that water gets dirty. So you need to clean that water out and then put fresh water in. Again, there's a maintenance cost there. So the next main topic in general conditions is traffic control. So work, again, is performed according to governing regulations or government regulations. The project traffic control management plan. So it can be an engineered sealed plan. So again, there's a cost for that engineer seal, as well as your company's corporate procedures. Again, I'm not going to get too far into this. It can also be its own course in itself. It's quite involved, traffic management, depending on complexity of roads and the speed limit of those roads. Some controls for traffic management can include things like construction signs, so TCPs, traffic control personnel, so concrete barriers. Maybe you need a detour route, which would need to be signed, some temporary access. So looking at detours, does the detour need to be paved? Can it be graveled? Those requirements would show up in the contract specifications. If the detour is existing roadways, then they're already paved. If you need to build a detour, then that's where the possibility of having to pave that temporary detour comes in. So there's the flag person or the traffic control person, TCP. So they've got all the required gear. They have to take a course to do this. So there's a cost to that. Some equipment shown here. So some detour examples. So this section of road looks like it's closed. So there would be a whole bunch of detour signs showing the traveling public how to get around this closed road. Of course, those signs would be on either end of the closed road. So you would need a detour sign at every corner where you want traffic to change directions. So you could have 24 or more detour signs on a detour. So the next major heading in general conditions is survey. So survey layout. So that's the X, Y, Z coordinates. So 3-dimensional coordinates in civil works. So for all the different elements that you're building, they all have these coordinate systems. So the surveyors go out and lay all that information out for you. So confirm who's performing the survey. So is it the owner or is it the contractors responsibility to complete the survey. So things here like control layout versus construction survey. So control layout are things like benchmarks. So there's maybe 2 or 3 or 4 different survey points that have XYZ coordinates that are provided possibly by the city. Then your construction surveyor comes along, relates to those 3 or 4 different points that the city has provided, and based on the location of those points, the construction surveyors are then able to lay out the construction project. So again, there's a cost to survey layout, whether it's your own personnel doing it or you have a sub that's hired that does the layout for you. So survey deliverables, so what do you get out of the survey? So things like ongoing construction surveys for measuring quantities, so measuring cuts and fills. That's sometimes a requirement of a contract. All excavations and all fills need to be surveyed so that you're paid accurately. That doesn't happen with every contract, only some. So you have ongoing layout as you're doing different things. So maybe you have a stripping and an excavate to subgrade layout. So that would be one set of stakes. So once you go ahead and do that with your excavator and the rest of your crew, you likely lose all those stakes. So then the surveyors come back in and say, okay, well, we need to re-stake for the fills. So that's a new set of stakes. So you build all the fills. By then, all of those stakes are gone. So then you get new stakes for road subbase, etc. This last survey here is the as-built survey. So once the project's done, the surveyors would come through the job and pick up in, again, this XYZ coordinate system, all the different pertinent items. So all manholes, all inverts of all pipes at those manholes, all catch basins, all head walls, other things. It really depends on what you're building. So you provide this as-built survey information, you give it to the owner, who can then update their drawings for any future work. So a couple of more survey photos. So there's the surveyor with the total station. So there's the rod person, rod min I was going to say, but rod person. So they are, looks like they're shooting the gutter line of this curb. So maybe they're as-builting the curb. There's some sidewalk forms here. Looks like some of the sidewalk's been poured. This next section has been formed. So road staking, so stakes are put up, maybe there's paint put on the ground. So it looks like maybe the stripping has been done here. Maybe these are excavation stakes down here. So the crew down here is working. So they're cutting to subgrade. So the next main heading in general conditions is materials testing. So know the scope of material testing. So who's performing the testing? Is it you, the contractor, or does the owner hire the materials testing company and do the testing for the project? So if it's you, the contractor, doing the testing, obviously there's a cost to that. So what are you testing? So things like imported materials. So you're testing densities, you're doing proctors, you're doing sieves of gravels. So this doesn't really apply to quality control testing, to material testing. This is a different type of test to confirm that material being supplied to the site is not contaminated. Typically, the gravel suppliers will provide you with that certificate. So I mentioned here the material gradation, so that's your sieve analysis. So making sure that the gravel that's being provided, so for example, road base, 19mm road base, there's a specific curve of of a gradation of gravel that you're allowed to be in. If the gravel falls outside of that curve, then that gravel does not meet spec and you cannot use it. So you need, your quality control company needs to continually sample the gravel that's being supplied to the job site and confirm that it's within specifications. So materials hauled off-site. Again, you have to confirm, you the contractor have to confirm to the dump site that the material, so the excavation that you're hauling them, isn't contaminated. So again, that's different than materials testing. That is sometimes provided by the owner. They've already done that. So this is, here is your main materials testing. It's the in-place testing. So testing concrete. So you're pouring curb, or you're pouring sidewalk, or you're pouring a slab on grade. So you're testing that concrete. You're testing compaction of gravel. This one is not materials testing, it's pipe testing. So pressure and chlorination testing. So that's a different company. That's when you are installing pipes. So specifically water main are pressure and chlorinated. So last bullet here, may be included as part of the scope of work, not as a general condition. So what does that mean? There may be a bid item for materials testing. So that would not then be a general condition. There would be actually a tender item that you would put a cost in. So here's some photos of material testing. So here's in the lab doing a sieve. So all of these different trays have different sizes of sieves in them. So based on the material that's left behind in each sieve, the tester can create a curve of where that sample falls, and they can test it to the allowable curve to make sure that it's within tolerance. So here's some pipe testing. So there's a temporary cap on the end. It's bolted on. There's it looks like this is the bleed off line. So this other end of the pipe is where the water is pumped into the pipe. So possibly with a fire hose. So a 50 millimeter diameter hose is attached on the far end here. So it's blowing water into this pipe. You crack this valve open to let the air out. Some water will leak out as well, but the purpose is to fill this completely with water and then pressurize it to see if there's any leaks. So the next main heading in our general conditions is mobilization and demobilization. So that's your equipment on and off site. Again, maybe it's a bid item, maybe it's a specific item in the tender called mobilization. So if that's the case, you would put your MOB costs into that bid item. If there is no MOB tender item, then you would, as well as all the previous general conditions, you would lump all these together and they would be called your indirects. So they don't go into a bid item, a specific bid item. So work not associated with unit price items, so I've mentioned that in the past. So includes for effort to, yeah, so it's bringing your equipment to the site in order to start building the project. So not only your excavator, your dozer, your packer, but things like your site office. Maybe you've got containers with all your small hand tools, so bringing that stuff. Maybe you've got disposal bins, so that could be termed MOB costs. So transport of equipment, so preparing your laydown area for your site office, equipment storage, etc. So assembly, disassembly of equipment. So if you have a large crane that you need on your job site, it doesn't get brought to the site in one piece. it comes in multiple pieces, and then it needs to be assembled on the job site. So of course there's a cost to that. So here's some MOB or a MOB picture. So here's a low bed with a sheep's foot packer on it. So the truck brings it, offloads it, goes and gets the next piece of equipment, brings it back, etc. So here's a site laydown area. So this is obviously quite a large compound here. So they've got crew vehicles here. There's some site offices. Looks like you can see the site fence. The security fence likely goes all the way around. Yeah, there's some stockpiles for different types of materials that they bring in. Hard to tell what that is. Looks like there's a crane here, other cranes back here. So not all projects have a site compound that's this big. I mean, obviously the job size needs to be huge in order to have a site compound that's this big. So costing, so establish the items that you need. So are they needed on an hourly basis? Are they needed on a daily basis, weekly, monthly? Are they lump sum purchases? So things like silt fence, you don't rent those by the week, you buy rolls of silt fence. You rent security fence by the month or by the week, depends on the duration of the project. So do the costs apply during work hours only, or do they apply after shift? So for example, if you have a generator running maybe a dewatering system, for example, that generator needs to run 24 hours a day because your dewatering needs to be maintained on a 24-hour basis. Conversely, if that generator is powering your site office, maybe the generator only runs while you're working. So maybe it's 8 hours a day, maybe it's 10 hours a day. So get extra quotes. So include for what is mandatory. So the specs will tell you what is mandatory. Use your careful judgment for the things that are nice to have. Again, you're trying to be the low bidder on the project. So including a whole bunch of these nice to haves will make everybody happier on the job site, but it's increasing the cost of your tender, which likely means you're not going to be the low bidder. So there's a balance here. You have to include this stuff. Maybe you only include some of this stuff. Again, it's a judgment call. There's more to construction than what is shown on the drawings. So that's the end of the PowerPoint. So I have uploaded the exercise, so today's exercise, to the Learning Hub. I did that previously, just confirm that it's there. Yes, so it's in the week 6 handouts. So the PDF of the PowerPoint presentation is there, as well as exercise 6 for general conditions. Notice when I was going through the PowerPoint presentation, I kept on saying the next major item in general conditions. So those are all the capitalized titles at all the PowerPoint pages. Those are the tasks of work that you're going to be calculating in this general condition exercise. So you should have 5, 6, 7, something like that, different tasks. So your job will be to determine the amounts of each of the general condition items you need, and then cost each one of them and provide a total cost at the bottom. So again, that exercise is due at the start of next week's class. Any questions? that's all I have for everybody. So if there's no questions, we will see you all next week. Okay, I'm going to stop the recording and I'll post it tomorrow morning at some point. So we'll see you all next week. Have a good weekend, a good long weekend.